Next we have Artem Blagodarenko. He is a PhD computer scientist. He works for Seagate. He's been a member of our community since 2011. His talk is going to be on scaling LDISKFS for the future. Again, let's give him a hand.
Good morning. LDISKFS is still actual and allowed to build large and fast Lustre FS backends. Last year, I presented scaling LDISKFS for the future, and the future is now and here, and we already have large solutions in production that use this code. Last year, we fighting with 6 terabyte and 8 terabyte disks. And this year, the next goal, next future, now the disk become 10 terabyte and 12 terabyte. And the targets that are built from such disks become up to 500 terabytes. And such a large partitions gives new goals, new problems. I'm starting from goals from last year and from last presentation. Then we made some code review, added some new tests, prepared patches, sent them upstream. So everybody who use LDISKFS can move to the new scale to 256 terabytes. And that time we pointed to some long-term problems that should be solved before moving forward. So it's inode count, other 64-bit counter, large memory blocks allocation, and solution for storing many files in the same directory. So since that time, some things are solved. I'm starting from inode count limitation. The problem is that customer asked to build some MDT, for example, that has 16 billions of inodes. Currently, this is a problem because one MDT allows to create only 4 billion inodes. So this is picture shows that we can use only part of the real target. Yes, we could use DNE that allows to split these inodes, other 4 MDTs, for example. But these disks are used only partly, so other part is empty on MDT. The best solution is make some patches, some work, and use all of the target for storing inodes on MDT. So have only one MDT and store this 16 billion inodes, for example. And currently we work on this solution. It was already discussed in XT4 email list, and the current solution is to use data in directory feature that allow us to store highest part of the inode number just after the name of the file. This feature already used for LU feed, so we can add some code that add highest part of inode number just after this direct LU feed. This have some opportunities. We spend less space to store these inode numbers. We can easily upgrade from the partition without this feature to the new one. and this has backward compatibility. Minuses this idea not obvious. The obvious one is just use 64-bit inode counter something in the inode structure. And this requires some extra code, but this is not the big trouble. Another problem is a large directory. Currently, for common file names, we can store only near 10 million files in the same directory. The reason is because LDISKFS is limited. LDISKFS directory is limited to 2 gigabytes size and to level 3. But if we want to make very large targets, we expect to store many files in the same directory. So we need solution, and solution already exists. We can add one more extra level to the file names tree and extend this 2 gigabyte directory. But this solution required some steps to complete. Because this is LDISKFS very related to the ext4 file system, it is more, the best solution is send upstream first and then cherry pick it from ext4. So original code exists since PDROP's feature. We added E2FS procs support, added some tests, prepared some testing to show that it works as expected, and sent it upstream. And currently this is in landing state, so we are expecting it will be landed to a kernel soon. So testing shows that performance drop is not so large, and give enough speed to use this feature. We tested it on 120 million inodes using LDISKFS partition, created only hard links, and using create many utility. We used hard links because inodes creating can add some other troubles, but we want to see influence only directory names. So this is the problems from last year research. This year new problems arise that need to be solved. First of all, we tried to format the large partition and faced the problem that the current settings inode count is larger than 4 billions. Yes, we can adjust some parameters like inodes per bytes rate, but we added the patch that automatically adjusts it to the biggest one value, to the 4 billions. Also, we verified code that large memory structures are located right way. The actual problem, and the most important, is the group blocks count that currently is ready only for partitions under 256 terabytes. This is because of ext4 design, but there is some solution. I will discuss it later. Actually, we had test for X-Ator's large inode number support. So group blocks count problem is that all group blocks information are stored only in the first group block, and it has the original size, and actually we can make only 256 terabyte partition. There is two solutions how to solve this. First one is MetaBG that split group blocks across the partition. And other one is BigLog that just increase the block size. MetaBG as shown in this picture. We have some part of we split the partition to the meta big group block blocks and place block groups to the start of this group. So we can allocate enough group blocks we need and solve our original problem. This method required add some fixes, land some patches from upstream ext4 code, and develop some new patches. Patch added that enable MetaBG feature, then first block group is become full. Also, there is a problem that partition that enabled MetaBG is mounted a long time, so we added a read ahead to the E2FS procs and to the libx2 library. Also, MetaBG parameter cannot be used with resize parameter, and patch was added that exclude resize automatically, so we can use MetaBG option. So I mentioned the problem of mounting a partition with MetaBG. This is because now group blocks are located other partition, and if this hard drive, the head need to move it to different parts of hard drive. This is random IOs, and such IOs are many IOs, near 37,000 for 300 terabytes target. The solution is to add read ahead for group blocks, and this reduces mount time dramatically. Now 300 terabytes target can be mounted during 12 seconds. This feature is landed to ext4. So second solution is BigLog. We tried it also. This feature just make the group bigger, so we can store the same count of group blocks and increase it as we want. So there are two solutions, and we need to check to get one of them. We compared them and decide that currently MetaBG is better because it looks more stable. It has another advantages like it appropriate for small files, Existing targets can be extended without reformatting. There are minuses like more metadata stored on the disk. It needs to be uploaded to the memory during mount. So currently we choose MetaBG, but continue to researching BigaLog, and probably someday we switch to BigaLog feature. So to show that this new size of targets works good, we prepared testing. So we built a large target, mounted it as LDISKFS, and check that LTFS procs utilities works for such targets. Executed some stress testing, run LLVRFS and LDISKFS, and made all the standard Lustre tests. So currently we can say that LTFS procs, LDISKFS, and Lustre code are ready for new storage size. And this storage size currently is 512 terabytes. So the reviews, patches, and testing that we made allow us to change this grade. And currently, such a large partition can be made without any options. This new patch is landed and ready for using. These solutions give opportunity for customers to have fewer but larger targets, the decrease resource requirements, and allows customers to deploy denser storage. Current work is landing large gear upstream and then to our branches, to the master, and use it in production. Developing 64 inode pointer solution and playing with BigaLog, fixing it, testing it to have all advantages that it gives us. And we do not forget that sometime the new hard drives arrived that have large size, and we need to solve new troubles. So we already think about these possible troubles. So work in progress. Thank you very much to Alexey Leshkov, Elena Gyoznova, who tested this, and Andreas Duder for ideas, reviews. Thank you very much.
Thank you. Very good presentation. So I have a question. So such kind of 10 terabyte and 12 terabyte, so much big volume. So it will cost so many times to take that FSCK, and also some problems, partial disk failure. So in that case, we have some need to accelerate the time to this FSCK, or some duplicate blocks, some protect some partial failure. Do you have some any idea to solution such kind of problems?
Are the solutions for what?
FSCK to too much time to 10 terabyte disk or something like that.
FSCK is ready for new target sizes. We fixed some bugs that exist.
Also, some partial disk failure block. So sometimes some blockers are collapsed and some are not released. So in that case, for a super block, some duplications of everywhere. So how about some?
FSCK needs still to be ready to correct data to restore, and these cases wasn't this case. Yeah, sure.
Any other questions?
So beyond E2FSCK, functionally working with such a large volume, are you planning to do any work to improve FSCK performance, like parallel, scanning or something like that?
Yeah, sure. We need some parallel solution, and these features are scheduled.
And there's also, I'm sure you're aware, there's a feature, metadata checksum, in newer versions of ext4, right, that allows, checksumming all of the bitmaps and group descriptors and all of those things. Have you done any testing with that feature yet?
So you suggest some special solutions for ext4 that can be helpful for Lustre?
No, it already exists in the ext4 code. It's just that we've never tested it, right? I'm just saying, so I can't remember what version of the kernel it's in, but there's a meta csum feature that already was written by Oracle. It's just that we don't enable it. We haven't used it. And I'm just wondering if you've done any testing with that feature.
So what is the question?
No, I'm curious if Seagate has tested the metadata checksum feature of ext4, and if you're planning to use that in the future.
So, Andreas, you know that we are currently working under some ext4 features, and you know everything, every features we are working currently.
Oh no, but I'm not saying this is not a new feature for you to write. I'm saying this is an existing feature, but I'm just wondering about the testing if you'd ever tried it. But no, okay.
Thank you.